1.2c. Remember we had piecewise functions. This is a piecewise function. f of x equals 1.5x for all x less than or equal to 3, and equals 0.5x for all x greater than 3. So normally when I have this in class, I have everyone sketch this on their own before we get together, just as something that you can do because it's good for you to remember how to do things on your own. Okay, but we're going to do it together. So let's go ahead and make a couple XY tables, input-output tables. All right, so for the first one, we're going to do right here. For all x less than or equal to 3. And to do that, our output's going to be 1.5 times x. All right, so let's pick something less than or equal to 3. How about 0? If we put a 0 in there, we get 0. Let's choose 2. That's less than or equal to 3. And putting 2 in there, 2 times 1.5 is going to be 3. And let's take another one. Well, how about 3? 3 is less than or equal to 3. So we put a 3 in there and we get 4.5. So let's graph those points. Okay, we have 0, 0. We have 2, 3. And we have 3, 4.5. 3, 4.5. All right. Now this is for all x's less than or equal to 3. So we're going to make this arrow continue in this direction because this covers all x's less than or equal to 3. All right. I'm going to give you a moment to write that because I kind of started on that pretty fast. Okay, so now let's look at x is greater than 3. So that's what we're going to do for this one right here. And that happens to be x and 0.5x. Okay, so a half of whatever x is. Greater than 3. So let's choose 4. 4 is bigger than 3. A half of 4 is just 2. Let's choose 5. 5 is greater than 3. A half of 5, 5 halves, which is 2.5. Okay, now we can't have it equal to 3 because it doesn't equal 3 here. But what we do is we just put it in anyway to find out where the open hole goes. So if we were to take a half of 3, we'd have 1.5. So let's graph that now. 4, 2 goes right here. All right, 5, 2.5. 5, 2.5 goes right about here. Okay. Now, if we could go to 3, it would be 1.5. 3, 1.5 is where our open hole goes. All right, now we're going to draw our line this way because this represents all x greater than 3. All x greater than 3. That's why we put the arrow that way. Okay, now notice this is not continuous. Not continuous. Okay, and if we were to take the limit, notice from the left and the right are two different things. From the left, we're approaching this number, 5. From the right, we're approaching this number, 1.5. So the limit does not exist there. Okay, so here's something new. What would it take to make what would it take to make the function continuous? What would it take to make the function continuous? What would we have to do to make it continuous? Well, I'm going to show you how we can handle that one. To start off, let me erase this. We're going to need more work for this. Okay. Ooh, I just erased what I wanted to show you. That's okay, I'll just do a quick thing here. Okay, we have an open hole here. Okay, so notice, what is the difference right here? If we were to count, you know, from here to here, this space right here, we're going to call that k because we don't know what that difference is. But what if we lifted this whole thing up k units? If we lifted this up, then we would look like this, right? So we have to lift it up k units. So in doing so, we still have 1.5x for x is less than or equal to 3, and 0.5x, and now what we want to do is lift this up k units for this one, so we're going to add k for x greater than 3, and that'll take it up. Now what is k? The way to find that out is we're going to take both of these and set them equal to each other. 1.5x equals 0.5x plus k. Okay, this will help us to find k. All right, now we notice this is at 3, right? So we're going to put 3 in there, and we get 1.5 times 3. Does that in fact equal 0.5 times 3 plus k? It will. We're solving for k now. So 3 times 1.5 is 4.5. 3 times 1.5, I'm sorry, times 0.5 is 1.5 plus k. All right, we solve for k, we subtract, minus 1.5 from both sides, and k equals 3. So if we wanted to change all this so that it was continuous, that's what we'd do. We'd actually let k equal 3, and we would rewrite this as f of x equals 1.5x for x is less than or equal to 3, and 0.5x plus 3 for x greater than